To interconvert between wavelength and frequency, all you need to know is that the product of wavelength times frequency is the universal constant, which is the speed of light in a vacuum. So wavelength has the symbol lambda, which I'm going to attempt to draw a funky little lambda there, and frequency has got the symbol that is nu, the Greek letter nu, and that is equal to C, the universal constant. Oh, that's not the color I was expecting. Let's fix that. Okay. And C is about 2.998 times 10 to the power of 8 meters per second. Okay, so wavelength is a unit of length, so we'd expect wavelength to be in meters, and the SI unit of frequency is hertz, and 1 hertz is inverse seconds. Okay, so all you need to know is that you can actually write equivalency of 1 hertz is 1 second to the -1, and you can use that to convert between seconds to the -1 and hertz. So in this case, we are asked to convert a frequency of 524 megahertz into wavelength, and I'm assuming that's in meters. So don't forget, you have to know your SI unit prefixes. Mega is 10 to the power of 6. So 1 megahertz is 10 to the power of 6 hertz. So there's my equivalency I'm going to use. And lastly, I'm going to have to rearrange this expression so that my wavelength is the subject. So wavelength then, whoopsie, that doesn't look very good at all, does it? It's supposed to be a lambda, y'all. Is going to be C over my frequency. Ugh. Okay, so back to typing. So 2.998 times 10, oopsie, to the power of 8 meters per second, divided by my frequency. And if you like, you can just write 524 megahertz and then do 2 unit conversions. So between megahertz, if I could type megahertz and hertz. So we're going to take that equivalency and put it into a conversion factor. 1 megahertz is 10 to the 6 hertz. Yeah, 10 to the power of 6 hertz. And then we want to convert hertz into seconds to the -1, just so that we can see how that will cancel out with our units, power of -1 of the speed of light in a vacuum. So I'll show you what I mean, because I like to make sure we are being consistent with our units. So that is C over our frequency, okay? And then converting megahertz into hertz. So there goes megahertz, okay? And then converting hertz into seconds to the -1, like so, okay? So then my seconds to the -1 is going to cancel out, leaving me with my wavelength in meters. I suppose I better grab a calculator and do that. All right. I should have probably grabbed a real calculator, not my phone calculator, but there we go. A phone, do that turny roundy thing. So 2.998 times 10 to the power of 8. You know what? I'm just going to pause this because this is boring for you. And I got 0.572 meters for my units. I can't remember if it just, ALEKS just says calculate wavelength, and I can't see what units ALEKS is asking for. It may be okay with meters, or looking at the order of magnitude there, it would not surprise me if ALEKS also asked you to convert that to millimeters. So just in that's the case, we can practice a bit of our unit conversion. So we know what the milli prefix means. Milli is 10 to the -3. So 1 millimeter is 10 to the power of -3 meters. That's my equivalency. So I could just take that, convert it into a unit conversion factor. So 10 to the -3 meters would go on the bottom, and 1 millimeter would go on the top, and that would give me 572 millimeters. So let me just get in there and draw some stuff. Okay, so if you were asked to do the other thing, which is if you were asked to convert, instead of from frequency to wavelength, if you were asked to convert from wavelength to frequency, again, you would just have to rearrange that equation, right? So if I was going to make wavelength the subject, sorry, if I was going to make frequency the subject, my bad. So frequency equals C over lambda. Okay, so it'd be the same kind of thing. All right, so I think that'll do on that one. So get some practice, and always ask for help if you need it.